So Sane reckons some kind of family of functions is likely to turn up. That makes it a really hard question to predict what they'd actually ask you to do, but it may look like something like this, fairly intimidating to start with. But remember, it is a calculator paper, but of course you can't plot that. Or can you? It, in fact, is the first thing I always do. Let's plot both of these and just make up numbers. So I tend to pick numbers that are prime, just to make sure there's no accidental symmetries. So I'm just plotting them. I'm just going to see what it looks like. And I've done a bit of zoom window and such like. It looks like this. And I think this is something that could come up on a calculator paper. They're going to pick graphs that don't go easily on a calculator. For example, this one, you think it's a little bit dull, but in fact, it looks to me like there is a point of intersection there. Well, we can easily find out by just doing gsolve intersect here quite clearly. When x equals 0, they're both equal to 1. But then we go to the left, I mean the right, and they intersect. It's so slow, even on this computer. They intersect at, oh wow, a round number. That's interesting. If I was struggling and I'd perhaps go back and say, well, maybe that was just luck to do with, I'd picked 5 and 3. Let's go for, say, 3 and 2, which means this, whoops, this one would be 2 and 3. And then draw that. Again, looks very similar, gsolve intersect. And that also hits at a integer, quite suggestive. So let's put them equal to each other and do it algebraically. Looks intimidating, but of course they've both got a +1 on both sides. Now in this situation, I'm going to divide everything by x, and then realize that we're in the world of quadratics, and the first thing you should be thinking is discriminant. And then, you know, who knows where the question will go, but we could use our knowledge of the discriminant. Maybe we know there are 2 distinct roots, in which case b squared minus 4ac has to be greater than 0. Might be able to get something from that. That's one possibility. Another possibility for like a series of functions or family of functions is they're looking at integration, which hasn't been huge in paper 1 and paper 2. So maybe it's talking about the area between the two. Whenever I see a diagram like this and I realize there's an intersect there and there, when I draw the sketch, I really try and exaggerate a little bit. I want to capture the overall shape and the important points, but I want to be able to see what's going on. So the area between them is f2 minus f1. I've done that based on my diagram where I can see the red one is, well, not very clear. Is the red one or the blue one above the other? You do it like this. The only difference if you got it the wrong way around would be it would be negative. So I'm not going to worry too much about that. So this is one way of getting the area between two curves. But in a question like this, I would definitely be doing it like that, where I'm going to combine it into a single integral. As long as the limits are the same, you can just combine these integrals. I'm doing that because things will start to cancel out. So that's a possibility. Another possibility is it's a question like this and they say something like ABC are in geometric progression. Maybe it's a two-parter where they're in arithmetic progression first and then geometric progression, and you have to find some symmetries. Again, you should be thinking, if this is a quadratic, the discriminant is bound to play some kind of role in it, and very much is trying to use the fact that they're in geometric progression almost certainly using this very important little equation leading to that. And maybe when you're doing the discriminant, you'll see a few b squareds around, and you then replace them with ac, and you've only got 2 variables, and that sort of thing. So I'm going to send another video on integration in a minute. Cheers.